Heritability. Heritability quantifies how much of the variation in a trait is due to genetic factors. Helps determine if a trait can be improved by selective breeding. Types. Broad sense heritability includes all genetic variants. Narrow sense heritability, only additive genetic variants. Broad sense and narrow sense heritability are crucial in plant breeding as they help determine the genetic and additive genetic contributions to trait variability, guiding breeders in selecting traits that can be effectively improved across generations. Heritability estimates are based on partitioning observed variation of a quantitative character into genetically and environmental controlled components. Phenotypic variance can divide into three components: genetic variance, environmental variance, and variance due to an interaction between genotype and environment. Heritability may be expressed as a fraction, or may be multiplied by 100 and expressed as a percentage. Broad sense heritability. Genotypic variance divide phenotypic variance multiply 100. Estimates based on genetic variance. Narrow sense heritability. Additive variance divide by phenotypic variance multiply 100. Estimates based on additive genetic variance. This is an example ANOVA table for the calculation of broad sense heritability. To calculate broad sense heritability, estimate the total genetic variance, which is equal to the mean square of genotypes. Total phenotypic variance is equal to the mean square of genotypes plus the mean square error. When we divide the mean square of genotypes by the mean square of genotypes and the mean square error, we obtain broad sense heritability. Variance components from ANOVA. Mean square for genotypes, this reflects the variation due to genetic differences among the genotypes. Mean square for error, this reflects the residual variation due to environmental factors and experimental error. Suppose an ANOVA for an RCBD experiment provides the following values. Mean square genotypes equals 45.7778. Mean square error equals 1.1111. Here, heritability suggests that 97% of the total variance in the trait is due to genetic factors. Higher heritability indicates a greater potential for selection and genetic improvement, while lower heritability suggests greater environmental influence. Heritability is a key concept in plant breeding, reflecting the proportion of phenotypic variation in a trait that is due to genetic factors rather than environmental influences. High heritability indicates that a trait is largely controlled by genetic factors, making it more reliably passed on to the next generation, which is ideal for selection and breeding programs. However, plant breeders face challenges when selecting traits based on heritability, as traits with low heritability are more influenced by environmental conditions, making selection less predictable. Additionally, even with high heritability, complex traits like yield or stress tolerance often involve multiple genes, interactions, and environmental effects, complicating accurate selection. Breeders must also consider both broad sense and narrow sense heritability, with narrow sense heritability being especially important for predicting additive genetic variance and the potential for trait improvement. These complexities make it essential to use advanced genetic and statistical tools to make reliable selection decisions and improve the efficiency of breeding programs. Thank you for your time.